there will be 3 dots will be there. There you can see option like make host or like that, co-host like that.
Okay, sir.
Yes. Okay. Okay, let me. Oh,
Recording in progress.
okay.
Okay, sir.
Fine. Okay. Yeah. Please share your screen. Can you able
I
to
think
share your
now
screen?
I can't share the screen, sir. I think host disable possible screen sharing. Okay, wait.
Yeah, I can give you. Yeah. Now you can, I think. Okay.
Can you see it
Fine.
now?
Yes. Yeah. I can see your screen. Yes.
So can you see now, sir?
Yeah. I can
The
see your
initial
screen.
design.
Yeah. I can see your screen.
So we created this initial from this research paper, sir.
Okay.
So we observe these S parameters like this. So my first question is
Okay.
Here with
Okay.
the number of flocket modes. So what's the mean of exactly this number of flocket modes?
The thing is, these flocket modes are defining the, I think, we can say number of, actually the thing is, if it is 2, it refers to the dual polarization. For example, not dual polarization. See, one will be in the TE mode, other one. Can you go to details, please?
Yes.
Yeah. There you will see only 2 modes are enabled. One is TE 000, TM 00. Can you see there?
Yes,
The
sir.
2 modes are enabled. Okay. Which means, see, one is in the vertical line, another one is in the horizontal line. So these 2 are enabled. For example, if you want to evaluate your unit cell in 2 polarization, then we have to use this. Yes.
So if we use number of flocket modes as 1, it gives only T mode.
Yes. Yes. One mode it will give. That's it. So there
So
I think if it is for linear polarized, then it's fine. One is fine. Yeah. If you are, unless you want to measure the cross polarization between two modes, then you can use these 2. Yes.
So distance to reference plane. So how do we calculate it? You said that
Lambda by
lambda over
4.
4.
Yeah. Lambda by 4. The thing is, why we choose lambda by 4 is like, for example, you are exciting the plane waves in the port that you defined. It is automatically defined in the flocket port method. So it is plane waves, that is, it travels to, for example, lambda by 4 distance, which means lambda by 4 distance corresponding to 90° basically in the sine waves. Well, full sine wave is corresponds to 360°. So lambda by 4, 1 lambda is corresponds to 360°. Lambda by 4 will become 90°. Okay. So 90° it is traveling, then getting reflected with a 180°. Then you are traveling again back to the 90°. So that's why usually we are, so that it will be in phase, because the whatever phase you are getting there, it's actually the generated by the unit cell. So that is why we keep this as lambda before. Yes.
So sir, the size of the unit cell is depend on the frequency.
Yes. The distance to the reference plane is depending upon the frequency. For example, usually we can select mid frequency. Okay. Mid frequency means so that you can cover both the upper end and lower end. Yeah. Yes.
So because they target on 5 gigahertz, but I calculated it because you have said that the unit cell length is should be lambda over 2. Is it?
Yeah. That size should be lambda by 4. But see, it's not necessary. I think some of the videos I think I might have discussed that lambda by 4 also it's fine. No problem. Okay. The thing is, see, lambda by 4 will have certain problems because you will not get enough reflection phase. For example, 360°, you will not get it. So that means it will create a phase error in the while constructing the array kind of thing. So that's why we go for this lambda by 2, so that you will have a freedom of, for example, you can vary the unit cell dimension over a long range, log range, so that you just get the required phase there. That's the idea actually.
Yes, sir. I meant the size, the unit cell size.
Yeah, yes. Unit cell size is lambda by 2
Uh,
usually.
lambda by 2.
Usually,
Okay, okay, yeah.
yeah, but no harm in using lambda by 4. What will happen is, can you go to that Z max 1? Z max 1.
Settings
Close
one.
this.
Okay,
Yeah,
okay,
close this one.
yeah.
No, down. The S parameters.
Okay.
Yeah, here you can see the phase is, for example, minus 152 plus 200, right? It is almost covering 360 degree. But if you
Mhm.
use lambda by 4, right,
Mm.
unless you have a complex geometry, then you will not get this phase actually. You maybe end up in, for example, maybe 100 degree, or total it will be less than 360 degree basically. So that's why
Okay.
usually it's like a compromise between this required phase range and other things. So we are going for that lambda by 2. And also, in principle, the thing is, it is also related to the array as well. So the thing is, in array, if you are keeping a lambda by 2, you will not get, means you can avoid the grating lobes basically. So if you are going for a, but in general, the baby satellite deployment, or they even use the what do you call, they even use this, what do you call, zero point 0.7 lambda as well. Okay, so that depends on the many factors in principle. One is, for example, radiation pattern characteristics. For example, if you use actually there is a many factors are there. One is, if you are going for large interlement spacing, then what will happen is you will have a problem in the generating the multiple beams. Okay, and
Yeah.
also beam width will have effect, because if you are increasing the spacing, then you have to apply appropriate weights to control that. Then if you start, shall I, can you open the any PPT, maybe Anat, can you see the screen?
Yes, sir. I can see.
Okay, here the thing is, see, can you open any blank page or paint or
Okay,
something like that?
okay, 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 sure. Um,
Yeah, it's fine. This is fine.
this
Zoom is
one, no?
also fine. Yeah. The empty Zoom is also fine. So the
Yeah.
thing is, see, you have an array like this. Okay, you have an array element like this. So if you increase this spacing, what will happen? Actually, you are increasing, indirectly you are increasing the array for given number of elements. You are increasing the array size basically.
Mhm. Yeah.
Correct? So
Yeah.
what
Yeah.
will happen is, see, if you increase the array size, you will get a high gain as well. Okay, but at
Mhm,
the same
mhm,
time, you will get a lot of lobes. You may get, for example, if you keep on increasing, then you will get a grating lobes as well. Okay, like this,
mhm.
grating lobes like this. Okay, both will have the same magnitude, almost same magnitude. So why it is coming? Because these elements are becoming independent basically, sub array. So it is creating a lobes like this, many lobes like this. Okay, so but this can be controlled by, for example, employing, for example, in some cases they use zero point 0.7 lambda as well. Zero point 0.7 lambda as the spacing. So there they consider many factors. One is beam width of the things, and the gain to be covered, and area to be covered. Beam width means in the sense that the area to be covered, and also gain, and what should be the gain at the edge. So many factors they will consider. Accordingly, they will fix this one, and then they apply the weights accordingly to these elements to get that desired performance basically. So it is like complex problem. See, that's why they normally use this lambda by 2 as the compromise between the gain and beam width, and also number of memes that you can generate, and beam scanning. For example, in some cases you may have to scan like this. Okay, beam scanning. So that is possible. There is I think a well-known relation, but I forgot now, between the beams, I think the beam scanning angle and versus the lambda, means sorry, interelement spacing. There is a well-known there. If you have a lambda by 2, you will have a compromise between all actually. So, so that is why, the lambda by 2 is something like kind of, you can see that it's like a, a nominal thing we can use unless you have any specific applications. Okay. Chale.
Yes, sir.
Yeah. So if you are using lambda by 4 also low harm, what will happen is, see, I will just explain that as well. So lambda by 2 is like a compromise for many things, radiation characteristics of the and the unit cell size, unit cell things. So and also in reflection phase. In turn, it will cause effect in the array performance, like that. So many factors are there. Okay, just 1 minute.
Okay, sir. Uh,
Just 1 minute actually. I will just show you. Can you go back to that page only? Can you just go back to
can
that
you see now,
page?
sir?
No, no,
I
I
don't
can
know.
zoom actually. Yeah.
Uh,
Uh, okay, where I have to. How can I do that? Oh, sorry. Yeah, can you see now? Actually, the thing is, um, what I was telling, lambda by 2 size, right? For example, this is the unit cell size, lambda by 2. Okay. For example, you have a square patch. Okay.
mhm.
So you will start keep on increasing the patch size. You will get like this. For example, size versus phase, right?
Yes.
So you will get like this S curve. Keep on increasing this. Okay. So
Mhm.
what will happen if you use the if you reduce the to 1/2, which means lambda by 4, then what will happen? You cannot increase, see, beyond certain point. For example, lambda by 2 is coming like this. Lambda by 4 almost will come over here only.
Yeah.
So let's say this is 0 degree, for example, normalized one. So this is around 380 like that. Okay. So if it is lambda by 4 stops here, then what you will get? Around 280 degree or 260 degree like that. Correct?
Mhm.
That's why, you have to compromise between these. But so the thing is, if you use lambda by 4 size, this problem is coming. Okay. That
Yeah.
you will have to your the entire phase range, right? The dynamic phase range reduces basically. So, but if you want to improve this one, the lambda by 4, you can use, for example, multiple dipoles or complex structures. Many structures are there. That, for example, the kind of this kind of structures. So that will give you the required phase range basically. Even here also, for example, like this. Okay, so you
Yeah.
can achieve that phase range. So that's why it is, see, the thing is, if you are going opting for this one lambda by 4, then your unit cell design should be such a way that you can do this. Okay.
Mhm.
So ultimately, why we need this dynamic phase range is minimum 360 degree. Why we need this? That, see, the thing is, see, you have an array, right? Array. Okay. Unit cell is here. Unit cell is here. Unit cell is here. Unit cell is here, like that. Okay.
Yeah.
So, for example, if you are constructing small array, it's fine. If you are going for a big array, what will happen is, see, this is the array. I will just translate it to a line like this. Okay, a side view. You have the feed like this. Then, for example, see, if you are going for a big array, this one and this one, the phase difference between the distance, right? For example, let's say this is R naught. This is Ri. Okay,
Mm.
so Ri is distance is increasing. So what you have to do? You have to the distance increasing means what? Actually, indirectly, it is phase is increasing. If you
Yeah.
know
First.
the
Yeah.
propagation constant, right?
Mm.
Propagation constant, what it says, okay? What it says is like mm, uh, uh, 2 pi by lambda is the propagation constant. Then this distance, correct?
Mm.
Ri
Yeah.
or Ro, okay? If you substitute, for example, let's say this is, let's say 1 lambda, okay? This, let's say 1.5 lambda, let's say 1.5 lambda or 2 lambda, like that. Okay, if you're going for big one. So this Ri is 2 lambda. This is 1 lambda. If you substitute here 2 pi by lambda into r naught, which is 1 lambda. So lambda get cancelled, you will get 360 degree. Correct?
Yeah.
Okay. Similarly, if you substitute r1, what will happen? 2 pi by lambda multiplied by 2 lambda. So lambda get cancelled. Almost you are getting 720 degree. Correct?
Yeah.
So now you have to put the unit cell that compensate for 720 degree. Correct? Yeah, so it will be less over here. For example, less over here, less over here, less over here. It's a kind of relative phase, basically. So here, let's say 360 degree. It is, phase it is introducing. Here it is introducing 720 degree, which means like this, 2 cycles. Okay. So it is taking 2 cycles to reach this destination. It is taking only 1 cycle to reach this destination. Understood? So this is introducing 360 degree. This is introducing 720 degree. Then what we are doing is like so now what we are doing, so if I want to compensate for this, right? I have to put a unit cell that gives me 360 degree. I have to put a unit cell here that gives me 720 degree. If you just compensate for that, then both get cancelled. Whatever comes out is a plane wave. Okay, that's how it works actually. So okay, so that's how it works actually. The thing is, see, that's why we are expecting a unit cell to offer that much phase, for example 720 degree or 520 degree, like that. But we cannot get that for 520 degree, 720 degree, but we can normalize this the phase. For example, see, your unit cell is only giving 520 degree, let's say 520 degree. Okay. Okay. So, but your requirement is, for example, 720 degree or 1500 degree, like that, and so on. So, what you will do is you will normalize this phase with this value, 520 degree. Okay. So, which means 520 minus 720, net phase difference is 200 degree. Okay. And here 360 versus, it's like a modular value, modulation of, for example, there is one function is there, a modular, this x value comma 520 I will put. So the remaining value, I will get it. That's it. So that way you can just see what is the the relative phase difference between these two elements. Okay. Then you apply for that. That's it.
Okay, sir.
Okay, so that's why we are to prefer that as much as 5 degree is possible, so that we can cover this point actually. So, but in a lambda by 4 also you can use, unless you have a complex structure there.
Okay,
to attain this one. Yeah, that's it. Okay.
Yeah.
Next out.
Next out is so we have been the polarization independent of scan angle phi. What's the meaning of that?
Basically, the scan angle means the thing is, see, it is like reflected wave, actually. Okay, so reflected wave, for example, your a reflected wave coming like this. Let me just do so for example, reflected wave is coming like this, in this way. Okay. Or in this way. Okay. So this should be, for example, here also you will have this two polarization ready. Okay. For example, whatever is getting reflected, still I am getting the two polarization. That angle only, this one. Okay. That's what I believe. I never use this, but that is what I believe actually. That's why they introduce only phi. So with respect to phi, if I'm reflecting like this, or like this, so we should not have any problem. But that kind of unit cell, I don't think maybe cross dipole will work like that. So we, that much symmetry we don't have. I don't see much. But normally we don't use this. That's it. Okay.
Okay, sir. So for here we have to put the maximum frequency, isn't it?
Yeah, but you can put even middle frequency also. Doesn't matter.
Okay.
See, it will matter, but to a certain extent. That's it.
So what is this circular polarization?
The thing is, if unit cell is you are designing for the circular polarization, then you can activate that and find out
Uh,
what is the response.
yeah, yeah. Okay.
Yeah.
So it's okay, sir. Then the phase shift and shift angles.
Yes. Okay. The thing is, your incidence is now it is normal, right?
Mm. Yeah.
Okay. But if you want to incident like this, that angle only is this.
Mm-hmm.
Okay. So in
Uh-huh.
theta, and if you just change the value of theta on the bottom, you can see here parameter list. There you will see theta 5.
Uh-huh.
On the bottom, you can see.
Yeah, yeah,
Can you go to there?
yeah,
There is a theta and phi, default value. Can you just put
yeah.
30 degree here, 30 degree here, maybe 60 degree or 90 degree like that?
Okay. I will.
Can store the results in cache. You just yeah. Okay. Then you change this here as 60 degree like that. Then go back and see.
Answer?
Here you just let me clear that. Here you make it a 60 degree. First I think, yeah, 60 degree. You make it as a 60 degree.
Okay.
Then you go and select this one and this one again. No, by first update the parametric.
Uh-huh.
F7. You press
F7,
F7.
F7. Okay. Yeah, yeah.
Then go here, boundaries, and then come back to here. Go to
Press,
boundaries. Yeah,
uh-huh.
yeah. Click on the face scan. Yeah, can you see here? Can you zoom a bit, please? Yeah, there is an arrow, right? There is an arrow. Can you see? It is in cross. Arrow.
Yes, sir.
This blue arrow. This one.
Uh-huh. Yeah.
Okay, that is to see. The thing is, how you interpret it. See, the thing is, my unit cell is like this, right? If you say this is the array, okay, this is
Mm-hmm.
the feed, okay. I may not expect, same plane wave like this, right?
Yeah.
Right. I may get
Mm-hmm.
incident like this, like this, like this,
Mm-hmm.
right? So this
Yeah.
incident angle may be 30 degree or 40 degree, whatever it may be.
Mm-hmm.
So it should not vary the behavior but too much. That's the idea here. Okay.
Yeah. It's okay, sir. Now. So this thing, periodicity and S2
This thing
periodicity.
is like, the thing is, you can just, along X, you can just,
Mm.
put numbers. It will just, look at the periodicity. Means it will repeat the same initial multiple times. That many times. That's
Uh-huh.
it.
Okay. So I'm good with that, sir. So thank you. Sir, which quotation we should take, sir? Here that it gives Cmax one, Cmax one again. It gives Cmax two, Cmax one.
Wait.
Uh,
So Z max is nothing but your the thing is, this is for do modes basically. Okay.
mm-hmm.
So max one means S11. Okay.
Yeah.
Of same mode, one mode. This
Mm-hmm.
is S11 of, like, cross polarization between two modes. This one and this one. T00 and TM00. Okay. This is again cross polarization of T modes. You will get the same thing. This is nothing but your S2, I mean second mode one. If you just click on this one and this one, you click one point here, just one point here. You click any one point here on the bottom. No, here, one point, any one point.
Here, here.
Yes, one point, and then you select both. 1 minute, I just clear that. So you select this as well. Control, select.
Uh-huh.
Okay.
Yeah.
Now Now second mode is, you can see here the green,
Yeah.
nothing, zero, right? Which
Mm.
means, which means that mode is, it is not dual polarized one. It is only single polarized one. Only one mode is working. Correct?
Uh-huh.
That's where we can just find out it is single polarized or dual polarized like that. If it is both are same, then it is actually dual polarized. Okay.
Yeah, yeah.
Similarly, this one and this one also you can check cross polarization between two modes. No,
Usually
not
we
this
should,
one.
what is the better, cross polarization or co-polarization?
No, this is co-polarization. Okay. This is cross
Yeah.
polarization.
This is co, no?
Yes, 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 yes.
So this is cross one.
Yes, yes. Cross polarization between yeah, it is TE and TM. Cross polarization.
So what you prefer? I mean, what is the better for reflect arrays? Co-polarization or cross polarization?
Both you have to check basically. So here it is actually cross polarization is very, very good actually. -75 and low. There is no
Hmm.
coupling between these two. That's why you are getting this. And if you check here, that is something you have to check. What degree you are expecting, all that stuff. Okay,
Mhm.
that's it.
Okay, sir. Then my other question is the array task.
Okay,
So here, yes,
simulation project. Yes.
so what are the results we can take from this?
The thing is, see, this is mainly for the patch antennas. See, like for example, you are designing one antenna, okay, one
Yeah.
small unit cell antenna.
Mhm.
Then you want to evaluate how it will be behaving in the, for example, 4x4, 8x8. Okay.
Yeah.
For example, you can see here, this is the values. You can just 4 and 4. You can even change the custom one shape, right? Shape also you can change circular, triangular like that. Then spacing, if you mention, so what will be it's the easiest way to kind of ideal result, but you will see so how the overall array performance looks like.
How can we go through that, sir? Overall performance?
Yeah, go to the customs you can select anything, you just click OK, that's it. Yeah, this is the array constructed,
Mhm.
right?
Yeah.
That's the, you can change the you can click on each one and then you can change the set the amplitude and phase like this. Can you see here?
Yeah, yeah.
Yeah, amplitude and phase, and then see what is the performance you are getting. That's it.
Mhm.
Okay,
Yes, sir. Uh,
you can see here there is a create full project array. Then if you create it, then it will be create a full project array, and then there is a unit cell also.
yeah. So we,
Okay,
okay.
there is I think there is one standard file is available from the CST, that how to construct the array and all that stuff. Okay, you
Uh-huh.
can go through that, you will get complete details
Okay, sir.
actually.
Uh, the thing is, my next question is, yes, again, so if we gave float mode as 2, it gives TE as well, TEM mode.
Yes, no, TE and TM.
Yeah, if we give
TE and TM.
if we give float mode as 1, it gives only TE.
Yes.
Yeah. Uh, then that's also, yeah.
Okay.
Mhm.
Okay. Welcome.
Thank
So
you,
thank
sir.
you.
Thank you very much.
No,
I,
no
I
problem.
mean,
Okay.
it's hard to find the different sources from the YouTube also. According to this subject, the PhD structures is not. It's hard. So you are doing a great job for everyone.
Thank you so much.
Thank you,
Thank you
sir.
so much for the compliment. Okay, thank you.
So,
Recording
sir, you are
stopped.
from Tamil Nadu, yeah?
Yes, yes, Tamil Nadu, Tamil Nadu. Yes, yes, yes.
Okay, sir.
Yes.
Thank you, sir.
Okay, welcome. Okay, take
Thank
care.
you, sir.
Yeah,
Thank you very much.
yeah.
Edit करते ही हूँ।